Hello students, how are you? Hope all you are safe at your home, stay safe. Today I am in front of you for your very first session on the chapter solutions, your second chapter of the from the syllabus chemistry. Before I start the session, today's session, I want to tell you some or few instructions. First, watch every session very carefully because I'm going to tell you some important and hidden points in the chapter. Secondly, in this chapter, in your textbook, some printing mistakes are there, some conceptual wise mistakes are there. So that points, it will be cleared from me. So what you have to do is that simply note down all the points during the session. So dear students, here we go. For the today's session, I want to begin today's session by your textbook, the PDF of your textbook. What is given in that PDF? Let us see. I want to share the PDF. Yes, this is the PDF of the chapter. Before I begin the chapter, I want to ask one question to you. Which is the first solution it is formed on the earth? What do you guess? Which one was the first solution that is occurred on the earth, our planet? Yes, the first biomolecule from which our life begins under seawater, the Jivan. For that, the pranavayu is required. Oxygen, the dissolved oxygen under the seawater, in water. And that first biomolecule, it is formed with the help of oxygen, air, and the sunlight. Okay, students. The chapter begins with the first definition of mixture. Here it is the mixture. What is given? The definition of mixture? Mixture, it is a combination of two or more substances. But I want to give you the precise definition of the mixture. It is defined as, mixture is defined as when two or more substances combined physically with each other in a different proportion by weight, it is called as mixture. What is the definition? When two or more different substances combined physically in a different proportions by weight, it is called as mixture. So here I want to trace the word physically because whole the chapter it is related to physically, means whatever may be the concepts are there given in this chapter, all these are dependent or related to physical changes. My dear students, we are not at all dealing with any type of chemical changes. This is the first point I want to trace you. Now, what are the examples of the mixture? Here it is given, air. Air, it is a mixture of different gases. Which are those gases? Air is containing oxygen, nitrogen, helium, CO2, etc. Different gases. And you know the different proportions of these gases. That will forms the mixture. Again, which are the different examples of solution or mixture? The rock, from which the metal is extracted. Rock, it is a combination of different minerals, different solids, from which metal is extracted by means of metallurgy. Now, here it is given that mixtures are classified as homogeneous, in which mixing of components is uniform, and heterogeneous, which have non-uniform mixing of components. Students, while classifying the mixtures, you have to remember two classifications of the mixture. First one is homogeneous and the second one is heterogeneous. What are the basic qualities of homogeneous mixture? They should form the uniform mixing. They should always form one phase and they look transparent. So these are the three basic qualities of the homogeneous mixture. Which are those one? They should be uniform. They are forming one phase and they looks transparent. Which is the second form of mixture, second classification? It is the heterogeneous one. Which are the heterogeneous mixtures? What are their qualities? Here it is given. The heterogeneous mixtures, they should form non-uniform mixing. So three different qualities for the heterogeneous mixture. They are having the non-homogeneous mixture. Then they may form one or the two phases. And the third important quality to form the heterogeneous mixture, it is that they may form the translucent or opaque type of mixing. So these are the three basic qualities for homogeneous mixture and heterogeneous mixture. Students, okay, what is given in the next line? We will see. We studied in 11th standard that homogeneous mixtures are classified according to the size of their constituent particles as colloids or true solutions. See the line. Here I want to highlight this word for you. This one. What is given? Homogeneous mixtures are classified according to the size as colloids or the true solutions. I think, students, this is the wrong word, because the mixtures are classified as the colloids or the true solutions, not the homogeneous mixtures are classified depending on the particle size as the colloids or the true solutions. Because when you will say that true solutions, they are obviously the homogeneous mixtures. But when you say that colloids, and what is here it is told, homogeneous mixtures are the colloids one. But dear students, the definition of colloids, it is that the heterogeneous dispersion of two or more immiscible phases, they are called as colloids. So now tell me, how the colloids that will be going to form the homogeneous mixture? So I think this is the wrong word which is printed in your textbook. So what you have to remember is that mixtures simply are classified as colloids or the true solutions. So here again I want to share my PPT. Here I am going to share my PPT. Yes, here is your PPT for the chapter solutions. We will move to the second slide. Yes, classifications of solution. Students, I have made 4 categories of classifications of solutions. In your textbook, only first classification is given, means the third classification that I have taken in the PPT. I have made 4 categories of the classifications of solutions. First one, general classification. Second classification, that will be dependent on the particle size. Third one, depending on the nature of solute and solvent molecules, which is given in your textbook. And the fourth one, depending on the number of solute and solvent particles or the molecules present in the solution. Let us see one by one. First, we want to begin with the general classification. First one, solute. Okay, remember that. All these definitions or the terms, again, obviously it is not given in your textbook. But These are the important definitions by means of which you can better able to understand the chapter. Solutions. So here the definition of first one, solute. What are solutes? The substance which is present in the small quantity in the solution, it is called as solute, which is in the discontinuous form. The substance which is present in the small quantity in the solution, it is called as solute. What is solvent now? Solvent, the substance which is present in the large quantity in the given solution, it is called as solvent. Again, which is of continuous phase, continuous form. So the solute, the substance which is present in the small quantity in the given solution, it is called a solute. The substance which is present in the large quantity in the given solution, it is called a solvent. Now here the third definition, solution, the name of our chapter, solution. Again, different definitions of solutions are there, but we are only dealing with the definition of true solution. What is the definition of true solution? True solution, it is a homogeneous mixture of two or more non-reacting substances whose composition can be varied within certain limits. Students, this is a important definition. I'm telling you, solution. And remember that we are, during this whole chapter, we are only dealing with true solutions, because there are the different types of solutions like true solution, colloidal solution, saturated solution. Okay, all these definitions are there, but only we are dealing with true solution, not colloidal solution. The colloids, surface chemistry, you have studied already in your 11th standard. So the third definition, solution, and this is regarding only with the true solution. What is the definition of true solution? It is a homogeneous mixture of two or more non-reacting substances whose composition can be varied within certain limits. This is the correct definition, obviously, which is not given in your textbook. So, for the formation of true solution, two or more non-reacting substances. So for the formation of the solution, two substances, minimum two substances are needed. The substance which is present in the small amount, it is called as solute. The substance which is present in the large quantity, it is called as solvent. Combination of both one, it will be going to form the solution. Again, it is told in the definition that the combination of two or more non-reacting substances, homogeneous mixture of two or more non-reacting substances whose composition can be varied within certain limits, means combination of the solute with solvent, it will be going to form your solution, but they are not going to react with each other at all. Already I have told you, the whole chapter, it is related to physical change only. We are not dealing at all with any type of chemical change, because the term is important, physical change, physical mixing, because in the chapter different concepts are there that we are going to see in our next session. So solute, solvent, solution. And the solutions are of two types, homogeneous one, heterogeneous one. Homogeneous, example is true solution. Heterogeneous, they are called as a colloidal solution. Okay, what are the examples of true solution? Take water in a beaker and dissolve 1 tablespoon of salt. Stir it very well. It will form your true solution, which is containing salt and water. Here in the salty water, your true solution, which one be your solute? It is the salt added to water, which is present in small quantity. And which is your solvent? It is the water, which is present in large quantity. And remember, dear students, whatever may be the physical state of solvent is there, that will be the physical state of your solution, true solution. So solutions are classified as the homogeneous one, true solution, heterogeneous one, colloidal solution. Now here the fourth definition comes, solvation. Solvation. What is solvation? Interaction between the solute and the solvent molecules. It is called as solvation. When you will add a solute, the substance which is present in the small quantity, to the solvent, the substance which is present in the large quantity, they are going to form your solution, true solution. Now, while stirring some solid particle, the salt, NaCl molecules that will be going to interact with the water. Our previous example, salt water. In the salt water, the salt, added salt is, it will act as the solute. The water present, it will act as the solvent. And that will be going to form the solution, true solution. During the formation of the solution, some interaction that will begins among the solute and solvent, the added salt and the water molecules. The term is called as solvation. Interaction between solute and solvent molecules. Now we will move for the next definition, next term, that is aquation or hydration. Simply remember that when the solvent, it becomes water, then and then only the term aquation it is applicable for the true solution. If your solvent is water, then use the term aquation or hydration. Got it? Then dilute solution. What is the definition of dilute solution? First, I will tell you the definition. The solution which is containing very small amount of solute present in the given solution. It is called as dilute solution. For example, again, take water in the beaker, add 1 tablespoon of salt. Definitely it will be going to dissolve. When it will get dissolved completely in water, it forms dilute solution, because we added the solute, that is salt, to the smaller extent in the large quantity of water, which is your solvent. Now, what are the concentrated solutions? Simply, the solutions which are containing large quantity of solute added to the solvent. It is called as concentrated solution. Now tell me, we are saying that solute, the substance which is present in the small quantity in the given solution, it is called as solute. What is solvent? The substance which is present in the large quantity, it is called as solvent. Then how can you say that add a large quantity of solute to the solvent that will make the concentrated solution? Yes. Instead of adding only 1 tablespoon of salt to the given quantity of water taken in a beaker, add 3 or the 4 tablespoon of salt. Make sure that 4 tablespoon of salt, the overall quantity of 4 tablespoon of salt, it should be less than 37.5 grams in 100 gram water. Because when you will add 37.5 grams of the salt to the 100 gram water, that will be going to form your 9th definition, saturated solution. So To make a concentrated solution, add a solute less than its saturated quantity. That will be going to form your concentrated solution. Now, let us move for the next definition, unsaturated solution. Unsaturated. In Marathi, it is called as asantrupta dravan. What makes unsaturated solution? Simply, it is related to dilute solution. Add less quantity of solute to the large quantity of solvent, that will make unsaturated solution. To make the solution saturated, santrupta dravan, in case of the example of salty water, take 100 gram of water, to the 100 gram of water in a beaker. Now add exactly 37.5 grams of the salt. Dissolve it completely. It will form your saturated solution. Saturated solution. Got it? Now let us move to the next definition, that is supersaturated solution. Students, now what I'm going to do is that now in your beaker containing water, suppose I have added 37.5 grams of the salt. It will make the saturated solution. Now here I want to dissolve more salt to the same quantity of water. Is it possible? Again, another question for you. Tell me simply, when you will take water and when you add 1 tablespoon of salt, you will stir it very well. Now tell me, where that added solute particles, salt molecules goes? Definitely they are get entrapped in the void space of crystal structure of H2O. Then suppose I want to add to the same 100 gram of water 37.5 grams of the salt, and that will make the saturated solution. Again, here I want to add more quantity of the same water at the same temperature. What will happen when you try to add more quantity of solute, that is salt, more than 37.5 gram of salt to the same 100 gram water? Try it. The next particle which you are going to add more than 37.5 grams, the added next particle, it will be going to settle at the bottom. It is not going to dissolve in the 100 gram water. Now, what makes the supersaturated solution? Students, don't forget that to make a supersaturated solution in the same quantity of given solvent, you have to heat the solution. You have to increase the temperature. Then and then only the added next particle of the salt, that is 37.5 grams. When you are going to add 37.6 grams of salt, that will be going to definitely settle at the bottom because already the solution becomes saturated. So to make the supersaturated solution, you have to heat the solution. Then and then only you will get supersaturated solution. Otherwise, you will get the precipitation. And it is told that simply increase the temperature only by 10 degrees. You may able to get the doubly saturated solution. In case of saturated solution of salt and water, simply increase the temperature by 10 degree. You may able to get the 37.5 into 2 grams of the salt. It will be able to dissolve in the same quantity of water. So here what I want to tell you is that for making supersaturated solution, you need to increase the temperature. That is the important factor. Now let us move for the next definition, that is aqueous solution. The term aqueous itself indicates the presence of water. Obviously, here your solvent is the water. And what is about the solvents other than water? There are the large solutions which are containing your which are going to make the solution, and that solution, it is containing the solvent other than water. For that type of solution, use the term non-aqueous solution. The solutions which are containing solvents other than water. For example, the mixture of aniline and acetone, ethyl acetate and methyl acetate, chlorobenzene, bromobenzene. Got it? So these are the examples of non-aqueous solutions. Now here I want to move to the next slide. What is that? Here it comes, your second slide. Our second classification. We will move to the second type of classification. Yes. Classification depending on particle size. Classification depending on particle size. Students, already I have told you in the chapter only this one, the third classification table, it is given in your textbook. Still, I want to make the 4 classifications for the solutions. First one already I have discussed with you. The first classification, it is the general classification. In that we have seen the 12 definitions, the 12 terms, which are very important one that everybody should know. Now the second classification of the solution, it is depending on the particle size. Which are those one? True solution, colloidal solution, suspension, and coarse mixture. Dear students, we are going to discuss these 4 types of the solutions in the second classification in the next slide. And the third classification, which is given in your textbook in the form of the table, it is the classification depending on states of solute and solvent. So here we go for the third slide to know what is mean by true solution, colloidal solution, suspension, coarse mixture in detail. So here we go for the third slide. This is the third slide in front of you. In the slide, you might be watching the 3 beakers are there and the table is given. Okay, I will tell you one by one. Can you be able to identify which one is this solution, the true solution? Yes, correct one. You are guessing the correct one. This is your camphor solution. In water, camphor is dissolved and you get this pink colored true solution. This is your second solution. Guess what is that solution? It is the milk. And in the third beaker, I have taken the muddy water. Muddy water. Already I have told you, I'm going to discuss the second type of classification depending on the particle size. These are the true solutions, colloidal solution, suspension, and coarse mixture. We will see one by one. Remember that. Up till now, what we have seen, we have begun with the chapter of solutions. In that, we have seen the first definition, that is mixture. What is the definition of the mixture? Combination of 2 or more substances. It is called as mixture. It is printed in your textbook. But I have I told you the different definition. What is the definition of the mixture? When 2 or more different substances combines together physically in a different proportion by weight, it is called as mixture. And already I have told you, don't forget the word physically, because no any chemical changes there while studying this chapter, that is solutions. Then we have seen the four, I've told you the four classifications of the solution. First, it is the general classification. I've made it. It is not given in your textbook, but all the definitions given in the general classification are the important one that you should know. And which are the definitions I have included in the first classification? Again, I will take the brief revision. It is the solute, solvent, solution, then aquation, hydration. Then the next definition comes, which is that definition: dilute solution, concentrated solution, aqueous unsaturated solution, saturated solution, supersaturated solution, aqueous solution, and non-aqueous solutions. These are the 12 definitions I've included in the first classification, general classification. Which is our second classification of the solutions? It is depending on the particle size. So what makes the bifurcation of the solutions depending on the particle size? What are the different examples of the solutions? Already I have told you the salt solution, in which salt is added to water, that will going to form the salt solution. In water, you may add sugar, that will be going to form the sugar solution, your solution. Different examples are there. We have already seen the air, it is also the solution. Rock, it is also solution. The 2 rupee, 5 rupee coin, it will also forms the solution. Milk, blood, cloud, fog, mist, all are the different examples of solutions. But remember that we are only dealing with the true solution. The chapter is related to only true solutions. And you have studied this part, colloidal solution, in your previous standard, 11th standard, in the chapter of surface chemistry. So students, here we have seen the 3 slides. If you are having any doubts, any queries, any questions, feel free to ask me anything. I'm able to give you the answer for your every question, every query. Thank you.